Okay, in this video we're going to talk about the segment addition postulate and the angle addition postulate, and we're going to talk about how we use those postulates to help us solve certain types of geometric problems. So first we're going to note that a postulate is a statement that is accepted as true without proof. Now this is in contrast to certain other types of statements we're going to look at in a little while, which are called theorems. Theorems require proof. Postulates, however, we just accept those as true without proof. Now the first postulate we're going to look at is called the segment addition postulate. And the segment addition postulate just says if points A, B, and C are collinear, and if point B is between A and C, then AB plus BC equals AC. Now let's take a look at what this postulate means, and we're going to illustrate it using a picture. So first I want to draw points A, B, and C on a line. So I want to have a line, 3 points on that line so they're collinear, and I want point B between A and C. So let me put A here, and let me put B right here, and let me put C right here. Alright, so I have points A, B, and C, they're collinear, and I have point B between A and C. Now, according to the segment addition postulate, the length or the measure of segment AB plus the measure of segment BC is equal to the measure of segment AC. Well, let's say let's go ahead and put some measures on here. Let's say the distance from A to B, let's say, is 13 centimeters. And let's say the distance from B to C is, let's say, 19 centimeters. Well, then according to the angle addition postulate, I know the measure of AB is 13 centimeters. I know the measure of BC is 19 centimeters. So according to this postulate, the measure of AC is just equal to the sum of these two measures. So I add 19 and 13 together and I get 32 centimeters. 12, yeah. So this kind of makes sense if you just kind of think of this as like a ruler or something. If the distance from the end of the ruler to here is 13 centimeters, and the distance from here to this point here on the ruler is 19 centimeters, well, then this whole distance, I just add these two distances together. That gives me that whole distance. That's all this says. If AB is 13, BC is 19, then AC, I just add them together, and that's 32 centimeters. That's all the segment addition postulate says. And the segment addition postulate is going to be the first of our problem-solving tools in this video. So let's take a look at a problem and use this particular postulate, this problem-solving tool. Example number 1. Points S, D, and T are collinear, and point S is between D and T. If dt is 40, ds is 2x minus 8, and st is 3x minus 12, find x, ds, and st. Okay, so we're going to use our 4-step problem-solving process, and step 1 is we need to draw and label a picture. Okay, well, since I've got 3 points that are collinear, and I'm told S is between D and T, I just need to draw those 3 points on a line and make sure I put S between D and T. So here's my picture. S needs to be between D and T, so let's put D and T, and let's make S right here. Okay? Now I also need to label my picture. So let's see. dt is equal to 40, so that's this whole distance here. Label that like this. So that's 40. ds, that's this distance here. That's 2x minus 8. And let's see, st, that's this distance here. Put that down here. 3x minus 12. And I'm looking for x, ds, and st. Okay, well, I've got the first step of my problem-solving process done. I've drawn and labeled my picture. Now I need to set up and solve my equation. So now to set up my equation, I'm going to make use of this problem-solving tool that I just learned about, the postulate called the segment addition postulate. I'm going to use that, and the segment addition postulate tells me if I have 3 collinear points, and I've got this point between the other 2 points, that this whole distance here is equal to this distance plus this distance. So I'm going to use that postulate to set up my equation. So let's see. ds plus st equals dt. That's what the segment addition postulate says. So now I just take each one of my values here and I substitute them in for ds, st, and dt. So let's see. ds is 2x minus 8. st is 3x minus 12. And dt is 40. Now I've got my equation set up. Now I just need to solve my equation. So let's see. I combine my like terms here. That's 2x plus 3x is 5x. Combine my like terms here. Negative 8 and negative 12 is negative 20 equals 40. I'm going to get all my constant terms together, so I need to add 20 to each side. That makes my 20s go away here, and I've got 5x equals 60. I divide both sides by 5, and I have x equals 60 divided by 5, which is 12. Now remember, there's a fourth step in our problem-solving process, which is I need to ask myself, put step 4 over here, am I done? In other words, I found x, but is that all I needed to find? Well, let's go back and see here. My problem says find x. Okay, I got that. I'm also supposed to find ds and st, so no, I'm not done. I have to find ds and st. Well, according to my picture, ds is equal to 2x minus 8, so ds is 2x minus 8, but remember, I know what x is because I just found that. So if x equals 12, I can just substitute my value for x here, and I have 2 times 12 is 24 minus 8, and let's see, minus 8, that would be 16. So I have ds equals 16. And now I'm still not done yet. I need to find st. Well, let's see. According to my diagram, st is 3x minus 12. And again, I know what x is, so I just substitute that in. 3 times 12 minus 12. 3 times 12 is 36 minus 12. That gives me 24. So I have st equals 24. And now I'm done. All right, let's take a look at example 2. Example 2 says points S, R, and T are collinear, and S is between R and T. If RS equals 3x plus 4, ST equals 2x minus 5, and RT equals 34, find x and ST. All right, again, we start with the first step in our 4-step problem-solving process, which means we need to draw and label a picture. So points S, R, and T are collinear, and S is between R and T, okay? So here are 3 collinear points. I need S between R and T. Okay, drew my picture and I need to label it. RS is 3x plus 4, so 3x plus 4. ST, 2x minus 5. And RT, that's this whole distance here, is 34. All right, so I've got step 1. I've drawn and labeled my picture. Step 2, I need to set up my equation, and then step 3, I'm going to solve it. So let's see. Step 2, I want to set up my equation. Well, I'm going to use, once again, the problem-solving tool I just learned about, which is my segment addition postulate. My segment addition postulate tells me if I have 3 collinear points, then this length plus this length is equal to this whole length here. Well, so now I can set up my equation. My segment addition postulate says RS plus ST equals RT. So now I just need to substitute these values in. RS is 3x plus 4 plus ST is 2x minus 5. It's a plus sign. And RT is 34. So now I have an equation. Now I just need to solve my equation. So let's see. Collect my like terms. 3x plus 2x is 5x. Positive 4 and negative 5, that gives me negative 1 equals 34. I want to get all my constant terms together, so I'm going to add 1 to each side. My 1's go away here, so that gives me 5x equals 35. Divide each side by 5, and I have x equals 7. So now I'm finished with step 3. I solved my equation. Now I need to remember step 4. Am I done? Well, let's see. It says I need to find x and st. Well, I found x, but I haven't found st yet, so I'm not done. So let's see. What is st equal to? According to my picture, st is 2x minus 5. I know what x is because I just solved it for it. So I can put x in here, put 7 in for x, and now I just need to solve that. 2 times 7 is 14, minus 5. 14 minus 5 is 9. Therefore, st equals 9, and I found x and st, and now I'm done. Okay, next we're going to talk about the angle addition postulate. And the angle addition postulate is very similar to the segment addition postulate, except, as the name implies, we're talking about angles. The angle addition postulate says if point D is in the interior of angle ABC, and interior, by the way, just means inside. So if point D is inside of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. All right, let's draw a picture and see if we can maybe illustrate a little better what this postulate says. Point D is in the interior of angle ABC. Well, let's draw an angle over here. Angle ABC. A, B, C. And we have a point D that's in the interior of angle ABC. So let's say point D is right here. Then the measure of angle ABD, so angle ABD, I'm going to draw a ray here from B through D. And now this angle right here is angle ABD. So according to the angle addition postulate, the measure of angle ABD, which is this small angle here, plus the measure of angle DBC, which is this larger angle here, equals the measure of angle ABC, which is this whole big angle here. So if you think about it, that kind of makes sense. This small angle plus this slightly larger angle, if you add those two angles together, then you just get the whole angle. And that's all the angle addition postulate says. So if we say, for example, let's say the measure of angle ABD was 20 degrees. And let's say the measure of angle DBC was, let's say, 42 degrees. Then the measure of angle ABD is 20 degrees. The measure of angle DBC is 42 degrees. Then the measure of angle ABC would be equal to 62 degrees. And that would be the measure of that whole angle right there. All right, let's take a look at example number 3. This says point D is in the interior of angle ABC. The measure of angle ABC equals 4x minus 20. The measure of angle ABD equals x minus 4. And the measure of angle DBC equals x plus 6. Find x and the measure of angle ABC. All right, so I'm going to start out by drawing and labeling a picture. Point D is in the interior of angle ABC. So this is going to look like the picture I just had. So I'll just make one. Here's ABC and here's point D. I'm going to go ahead and draw my ray here through my point because I know I'm talking about angles here. So I drew my picture. Now let me label it. The measure of angle ABC is 4x minus 20. So ABC is this whole large angle. So let me put that like this. ABC is 4x minus 20. Measure of angle ABD equals x minus 4, so that's this small angle here, or at least it's a small angle in my picture. And the measure of angle DBC, that's this angle, is x plus 6. Find x and the measure of angle ABC. Okay, so I've drawn and labeled my picture, so I've got step 1. Now I need step 2, which is to set up my equation. Now in this case, I know that the problem-solving tool that I'm going to use is the angle addition postulate, the one I just learned, because I've got a picture here in which I have two small angles that are going to add together to give me my larger angle. So according to my angle addition postulate, the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Now I've got expressions for each one of these angle measures. I just need to plug those in. So measure of angle ABD, that's x minus 4, plus measure of angle DBC, which is x plus 6, equals the measure of angle ABC, so that's this whole large angle, and that's 4x minus 20. So now I've set up my equation using my problem-solving tool, the angle addition postulate. Now I just need to solve my equation. So let's see. Put my x's together here. That gives me 2x. Negative 4 and positive 6, that's positive 2. Equals 4x minus 20. Let's see, if I subtract 2x from each side, that'll get all my x's together on one side of the equation. X's go away here. 4x minus 2x is 2x. Oops, that's a minus. And let's see, if I add 20 to both sides, then that'll get all my constant terms together. I have 22 equals 2x. Now I want to divide each side by 2, and I have x equals 11. Now I need to remember step 4, which is to ask myself, am I done? And let's see. My problem says to find x and the measure of angle ABC. Well, I have x, but I don't have the measure of angle ABC yet, so let's see. ABC, that's this expression right here. So the measure of angle ABC is 4x minus 20. Well, I know what x is because I just found it right here. So I can just substitute 11 in for x. So that gives me 4 times 11 minus 20. 4 times 11 is 44. Minus 20. That's going to give me 24. So the measure of angle ABC is 24. And now I'm done. Example number 4. Point D is in the interior of angle ABC, so right away I think I'm going to be using my angle addition postulate again. The measure of angle ABC is 108 degrees. The measure of angle ABD is x, and the measure of angle DBC is 2 times bigger than the measure of angle ABD. Find x and the measure of angle DBC. All right, well this one sounds a little more complicated. Let's see if we can break it down. First step, I need to draw and label my picture. So I've got point D in the interior of ABC. All right, so that one I think is going to look like the one I've been using before. Point D right here. Draw my ray here. I'll call this A, B, and C. So now I've got point D in the interior of angle ABC, okay? Measure of angle ABC is 108 degrees. So again, that's this large angle is 108 degrees. Measure of angle ABD is x, and the measure of angle DBC is 2 times bigger than the measure of angle ABD. Well, let's see. 2 times bigger than the measure of ABD. Well, ABD is x, so if DBC is 2 times bigger than that, then it must be equal to 2x. So now I've drawn my picture, I've labeled my picture. I just need to do step 2, which is to set up my equation. So let's see. I'm going to be using the problem-solving tool I just learned, which is the angle addition postulate. An angle addition postulate tells me that this angle plus this angle is equal to this large angle. So that's the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC, the large angle. So the measure of angle ABD is x. The measure of angle DBC is 2x. And the measure of angle ABC is 108 degrees. So I've set up my equation using the problem-solving tool, the angle addition postulate, and now I just need to solve my equation. X plus 2x, that's 3x, equals 108. Divide both sides by 3, and that will give me, let's see, x goes to 3, 18, x equals 36. Now, step number 4. Am I done? Let's see. I'm supposed to find x. I got x. Oh, and the measure of angle DBC. So I'm not done. Angle DBC, measure of angle DBC is 2x. And I know what x is because I just found it over here. So I just plug in 36 for x. 2 times 36 is 72. So the measure of angle DBC is 72. And now I'm done. Now in your notes you have 2 more problems, example number 5 and 6. I want you to try those on your own, and we'll take a look at those tomorrow in class.